Today we're going to work on graphing exponential functions. And in order to do that, we need to review what our parent function looks like for an exponential. So we'll start with 2 to the x, but really any number to the x power can be considered a parent function for the exponentials. So we're going to start with our y equals 2 to the x here. If we plugged in -2 for the x, 2 to the -2 power, remember a negative exponent flips it. So that would be 1 over 2 squared. So that is 1/4. If we put in a -1 in the place of the x, we would get 1/2. If we place a 0 in the x there, 2 to the 0 power is 1. Really anything to the 0 power, except for 0, is 1. So all of our exponential functions are going to go through the point 0, 1, unless they have some kind of transformation. If I plug in a 1 right there, that's going to be 2. And if I plug in a 2 there, 2 to the second power is 4. So there's our points to make our parent function here, 2 to the x. 0, 1 is going to be one of the key points where every single exponential is going to go through there as a parent function. So that is one of our key points. The next key point is going to be the 1. Anything to the first power is itself. So that's really important. Every one of our exponentials has the point 0, 1, and then the next point is 1 and whatever the base is. So in this case, it's 2. If this was 3 to the x, it'd be 1, 3. If this was 4 to the x, it'd be 1, 4. Same thing if it was a decay. If it was 1/2, then 1 and 1/2 would be our next point. So these 2 points are really important. 0, 1 is all of the exponentials, and then 1 and whatever the base is going to be your second one. Now I'll go ahead and graph the other points here of 2, 4, and -1, 1/2, and then -2 and 1/4. Notice that the increments get really close together over here. That graph is going to follow the x-axis there. And then once it hits that 0, 1, it starts to increase pretty quickly. So that's what our parent function looks like there. There are no negative numbers. It does not go under the x-axis. This is a horizontal asymptote on the x-axis because it follows that along forever. I do want to talk about one of the decay parent functions. So here we have y equals 1/2 to the x power. We said all of them go through the point 0, 1. And then the base here is 1/2, so we would have the point 1 and 1/2. Again, our horizontal asymptote is the x-axis, so it's going to move towards that. So we get something that looks like this on the right-hand side. If we wanted other points, so -1, if we place that here, a negative exponent does the reciprocal. So this would flip and give me 2. So at -1, we have the next point over at 2. So you notice that it grows very quickly on this side here. So that's the, this is a parent function for a decay. So 1/2 to the x power is one of our parent functions, and it will look like this. 2 to the x power looks like this here. Those are the two main parent functions that we'll be using in order to graph. Now we can go ahead and review the transformations, and we've been doing these all year, so we do this with every function. That does not change. This right here is the transformational form for a parent function. Remember, 2 is what's being raised to the x power. Sorry about that. So that just tells me what the parent function is. So I know to start with y equals 2 to the x power because that's what's being raised to the x power here. All right, everything else still works just like in the other functions. So our a value here, if a is greater than 1, it is a vertical stretch. If it is between 0 and 1, it is a vertical compression. And if it is negative, then it is a reflection across x. So that's up in the front. That's what's going to be multiplied times the 2. If it is bigger than 1, vertical stretch. If it's between 0 and 1, vertical compression. And if it is negative, then it is a reflection across the x-axis. We'll skip over to this part here because this is, we'll do the A, the C, the D are the easier ones for students. So x minus C here, if it is x minus C, it goes to the right C units. If it is x plus C, it goes to the left C units. And then our D, if it's positive, it is going to go up. And if it is minus D, it is going to go down. This also changes the horizontal asymptote. So remember, a horizontal asymptote is like this. If it moves left and right, that doesn't change a horizontal line. But if you move up or down, that does change a horizontal asymptote. So this one here changes our horizontal asymptote. So keep that in mind as you're graphing. The B is the harder one, and that's when we're multiplying here. Notice that it is factored out, so there should be nothing in front of that x. If that B is negative, then it is going to reflect across the y. If that B is greater than 1, it is a horizontal compression by 1 over B. And if it is between 0 and 1, it is a horizontal stretch by 1 over B. So that's kind of the opposite of the vertical here, because the scale factor is flipped. All right, so since there can be different parent functions depending on what this number is, that's the first thing you're going to want to do when you graph these. Given this one right here, I look at what's being raised to the x power, so I know my parent function is y equals 2 to the x power. 2 is what's being raised to the exponent. On this second one, I have 1/2 times 2 to the x plus 1 minus 3. Still 2 is what's being raised to the power. So this tells me my parent function, which would be 2 to the x power. That's what you're going to start with. The other pieces don't affect the parent function. You're looking for what is being raised to the x power. That's going to give you the parent function. All right, so we're going to look at some examples here, and we'll start with this first one. We've got y equals 1/2 to the x minus 5 plus 6. 1/2 is what's being raised to the power. So our parent function is y equals 1/2 to the x power. So this is a decay because this value is between 0 and 1 that's being raised to the x power. So that is a decay, exponential decay. Now we want to look at what our transformations are. We have this x minus 5 in the exponent, so I know it's going to go to the right 5. And we have this plus 6 at the end, so I know it's going to move up 6. All right, to graph this, we think about those key points that we were talking about on the other page. And so we said the horizontal asymptote is the x-axis. All of them go through the point 0, 1, and then we have the 1 and the b value, which in this case is 1/2. So we start with that horizontal asymptote. It's going to move up 6 units because of this. We said that changes your horizontal asymptote. So instead of being on the x-axis, our horizontal asymptote is going to be up 6 units right here. Horizontal lines are written as y equals, so that horizontal line is y equals 6. There's my horizontal asymptote. Now I'm going to do the same thing for my other points. So I've got a point at 0, 1. I'm going to move it to the right 5 and up 6. So there's my next point. And then we would do the same thing to the 1 and 1/2. We would move that to the right 5 and up 6, which is going to be right there. You can do that to the next point as well if you wanted, that -1, 2. And now you've got an idea of what your graph looks like. It goes through these points and towards our asymptote. So there is our graph. Remember, decay was a decreasing graph. Growth was an increasing graph. So this graph is decreasing as it moves to the right. So this would be a decreasing and it would be decreasing on all of our numbers, so all real numbers. It starts at the left and goes decreasing forever, which is also our domain. This graph goes all the way to the left as it goes this way, all the way to the right as it moves this way. For our range, all of our values are above that 6. And so this would be from 6 to infinity. Notice I have a parentheses there. That's because there is no point on 6. Remember, it's only getting close to 6. It is not touching. So this would be from 6 to infinity. We have just graphed it without a calculator, but I want to go ahead and show you it on the calculator as well so you can see it's the same. So here we go. When we type this in, we would type in 1/2, and I can go ahead and do that in our y equals here. We do 1/2, and then we use the caret symbol to get it up to the top. And we want to put x minus 5 and then plus 6. So when I type in the x minus 5, it's going to stay in the exponent. And then I want to use my arrow key to get out and do a plus 6. And now when we hit graph, here it comes. There is our graph, which is what we just got right here. It is following this line along forever and then going up. All right, we're going to try another one here. On this second example, as I look through this, what's being raised to the power is this 2. So our parent function is y equals 2 to the x power. That's the graph we're going to start with. There are 3 transformations here. We've got a 1/2 in the place of a, we've got a plus 1 in the place of c, and then we've got this minus 3 at the end here. So we have a vertical compression by 1/2. That's what this a value does. Remember, between 0 and 1, it's a vertical compression. The x plus 1 takes it to the left 1, and then the minus 3 takes it down 3. The only one of these that affects our horizontal asymptote is going to be this down 3. So we're going to start with that on the horizontal asymptote. We're going to go down 3. And there's our horizontal asymptote. Remember, horizontal asymptotes are written as y equals, all horizontal lines are y equals, and it is going through -3 there. All right, to graph our next point, we start at that 0, 1. To vertically compress that by 1/2, we multiply times 1/2. So that would take it to 0 and 1/2. Then we move to the left 1 and down 3. We do the same thing to our second point. So our second point was at 1, 2. We compress it by 1/2, so it's going to be at 1, 1. We move it to the left 1 and down 3. If you wanted to do more points, you could. That second point is at 2, 4. We compress it by 1/2, so it goes down to 2, 2. We move it to the left 1 and down 3. You can do points to whatever you feel comfortable in graphing this. So now it moves close to that asymptote, and then it moves up. And there is our exponential growth equation. This is an exponential growth because what's being raised to the x power here is 2. And since this is bigger than 1, it is an exponential growth. So this graph is increasing the entire time. So this would be increasing on all real numbers. Our domain is all real numbers, so it goes all the way to the left and all the way to the right. And our range is everything above this -3. There is nothing below it. So we start at -3 and go to infinity. Again, that is a parentheses because there is no point on -3. It is just getting close to that point and following it along. All right, to work backwards from this, they're always going to tell you what the parent function is. So here they're saying given f of x equals 2 to the x, so you know this is the parent function. This is what we would want to write it with. Write a function g of x that is reflection of f of x across the x-axis is 3 units to the right of it, and that is a vertical compression by a factor of 1/4. All right, so when we start writing this equation, we want to have 2 to the x power. That's our parent function. Now to get it to compress by 1/4, I know I need to multiply this times 1/4 in the front. That's a vertical compression. To get it to reflect across the x-axis, I need that to be negative up here. That's what does the reflection across the x-axis. And to get it to move to the right 3, I know up on top here in the exponent, I need the x minus 3. So this goes to the right 3, vertical compression by 1/4, and a reflection across the x-axis. So you want to work backwards from those transformations. Now we're going to address some of the questions that are a little bit harder that you have to put a little more thought to with transformations. At this point, we've done it with all the functions, so you should be getting pretty good with these transformations. Given this equation right here, it says, what is the asymptote? We said the only thing that changes the asymptote is the up and down movement. That's what's going to change a horizontal line. So that comes from this right here. If it went down 3, then I know my horizontal asymptote has to be at y equals -3. The y equals is mandatory because it is a horizontal line. It is not a number, it's a line, and the equation of a line is always with any y equals or x equals if it was vertical. Now it says the function is transformed right 3 and up 5. What is the asymptote after the transformations? Again, this right 3 does not change a horizontal line. If I take this horizontal line and I move it to the right 3, that is not changing that horizontal line. The up 5 does change it. So it would take it from this -3 and move up 5 units. So it would be at y equals 2. This does not change it. So you really want to think about what each part of those transformations is doing to your graph. All right, this next one we're going to look at here, it says the function f of x equals 1/2 to the x is transformed and is now defined by this table. So we want to look at this to write the new equation. You want to think about this parent function. Y equals 1/2 to the x. I like to sketch a picture just so I can keep things in mind. This is a decay function, so I know it's going to be decreasing and it goes towards my x-axis like this. I know its key points are 0, 1, and 1, 1/2. Those are the two big points that we want to look at. Now, as we're looking at this table here, we see that it is getting closer and closer to -5. It goes -4, -4.5, -4.75. Notice these increments are getting closer and closer together, and they all are headed towards -5. So we know that our horizontal asymptote has to be at y equals -5. That's what our graph is getting closer to. In order for our horizontal asymptote to be at -5, it had to have gone down 5 units. And so now I like to think about this point right here, 0, 1. If I moved it down 5, it would be at 0, -4. Well, that's where this point is. So I don't think it's moved to the left or right. The last thing I need to check for is an a value. And so we would take what we know, which is 1/2 to the x power minus 5. That's what I know so far. And I would put in a in the place of an a. And then I would take any one of these points and plug it in to verify that it is what this a value is. So I'm going to go ahead and take this very next one, 1 and -4.5. and plug in that point. So I get -4.5 is equal to a times 1/2 to the first power minus 5. I start by adding 5 to get it to the other side. That gives me 0.5 is equal to a times 1/2. My last step would be to multiply times 2 to get rid of this half to the other side. So I multiply this side times 2, so I'm going to multiply this side times 2. That gives me 1 equals a. So we have no vertical stretch or compression since a is 1. So our equation here would be 1/2 x to the minus 5. All right, this one's a little bit harder because it's talking about a transformed function already, and this one confuses a lot of students. It says, given the parent function y equals 2 to the x and this transform graph, what are the transformation and what's my new equation? I like to go ahead and graph my parent function there so I can really compare the two. So there is my parent function. One of the most obvious transformations I see there is that there's a reflection. Instead of growing upward, it is going downward here. So I know that there is a reflection across x. The other obvious transformation we see there is the horizontal asymptote has moved. It is right here. That is what the graph is getting closer and closer to right here. So we know our horizontal asymptote is at y equals 2. So we know this graph has moved up 2. These are the obvious ones. I should be able to spot those very quickly. So now I'm going to take this point, 0, 1. I know it's been reflected over the x-axis, so I reflect it and it goes over here to 0, -1. I know it's been moved up 2, so I move it up 1, 2. It ends up in the same place here. That is not on my graph. I need to move it to the left 1 to get it to my graph. So now I know there's another transformation there of left 1. To verify that there's no, excuse me, there's no other transformation like a stretch or a compression, I check the next point. So this point at 1, 2, I reflect it over the x-axis. I move it up 2 units, and then I move it to the left 1 unit. That is right here on my graph. So I know there's no other transformations because now both points have landed on our graph with those transformations. So our equation would be y equals a negative for reflection, x plus 1 to make it go left 1, and then a plus 2 at the end to make it go up 2. Now our domain and range for this new graph, domain is still all real numbers, which is true for all the exponentials. It goes all the way to the left, all the way to the right. For our range, however, everything is below this line of 2. So our range is from -infinity to +2. And again, with parentheses, because it's only getting close to that asymptote, it's not actually touching.